hear me? Yeah, I think you're on. All right. Hello, Joseph.
Hello.
Welcome on stage.
Thank you.
It's not the first time.
Yeah, it's the second time. So should I take it on from here?
Yeah, you absolutely can. Do you want any more introduction?
Not. I'll try to introduce myself. So, good morning, everyone. I'm happy to be here and happy to talk about having a minimal Django testing style guide. So this talk is probably formed from years of experience and from my perspective, because now I'm getting more into senior-ish roles, and so whenever I join a new project or a new company, I am joining as someone who is coming to an existing code base. And when we talk about existing code bases, the larger the code base and the more the people have worked on it, then it kind of gets scarier to join that code base. What is it that troubles us? What makes us anxious about it? One thing, for example, that job adverts make about some jobs is that you're joining to work on a greenfield project. So why is it that working on an existing project is scarier? And the image here is of broken windows. And in 1982, there was a criminology study that produced this broken windows theory. The theory says that if one broken window in a neighborhood leads to more degradation in that neighborhood. And the reasons they come up with are two. The first is signs of neglect lead to more neglect. And the second is that the people in that neighborhood sense a lack of ownership. So I think this can be applied to our work environments and therefore our code bases. You might say that it's just a broken window. It does not affect the structural integrity of the building, but it's the small things that then lead to degradation. And one thing which might appear small is our test code and test code bases. It might not be the production code itself, but our test code is one of those small things that if neglected, lead to degradation. And my answer today to that is to have a style guide in place. So a style guide has rules and guidelines. Guidelines are recommendations or best practices, whereas rules are laws people are meant to follow. So the style in style guide can be a bit of a misnomer, because the style guide is not only about code formatting practices, about code formatting rules and enforcing them via automation. We have Marika's talk right after this one. The rules and the guidelines in a style guide, for example, do's and don'ts about what to do in your test code, require more human judgment and more engineer judgment. So if we have a style guide in place, what do we gain and what do we lose? We lose, the individual engineers lose flexibility because their choices are restricted. However, we gain consistency. And consistency enables engineers to focus on what to test rather than how to test it. Consistency also results in expert chunking when we have a consistent way of structuring tests. Expert chunking is a cognitive process which groups pieces of information into meaningful chunks rather than keeping track of each piece on its own. This makes it much faster to think about things. For example, expert chess players think in terms of configurations of pieces rather than keeping note of each individual piece's position. This makes it faster to read tests, and this results in productivity. Consistency also brings productivity because you have engineers who jump from one code base to another and hit the ground running. And also, our code base is more resilient to time because if the people or players on that code base change, the code base itself doesn't need to change because of the consequent change in ownership. Finally, with this style guide, we have reduced conflict, especially at code review stage, because the engineers can focus on what is being delivered rather than how it was coded. So what should our style guide be about? It should tell us what to test and how to write these tests. So what should we test? And the answer is the Beyoncé rule. Test anything that you don't want broken. What does this translate to in our Django applications? We have to test anything that is not already tested by core Django or by the tests in the third-party applications, third-party packages our Django project uses. All right. How can we enforce that? How can we ensure that we are testing that? And there are multiple ways our projects, our code can be tested. So let's get some definitions done here. I'm by no means, this is a disclaimer, I'm by no means the authority on this, but I will spare the in my opinion prefix to sentences. So a unit test, we can say that a unit test, so if we're testing a function, that is the test target. So it's the target under test. So a unit test involves testing that target, and while the unit test runs, the target does not talk to any other component. Integration test, for example, in Django, when we're using the test client, it's an integration test. Why? Because if we hit the URL to test form validation, we're hitting the URL, the view that is bound, the form we're testing is bound to, and the form code itself. So it's an integration test because it hits multiple components. On the other hand, end-to-end tests or system tests test the whole, may talk to components you have no control over. So for the purposes of this talk, we will treat unit and integration tests as deterministic. Deterministic in this case means that their behavior is repeatable, whereas system tests, because they talk to external systems, they are non-deterministic. So this, the first pyramid is my const test pyramid. It's from the book Software Engineering at Google. I will give references later on. And they advocate at Google to write a huge amount of unit tests compared to integration tests and end-to-end tests. Why? Because as Martin Fowler's test pyramid shows, unit tests run faster. You also develop them faster because they have a narrow focus, they are smaller, and since they run faster, they are easy to run on your own machine, they discover bugs earlier. That's why the cost of both running them and them finding bugs is smaller. On the other hand, the closer you move to the user, the slower the tests become, and the costlier it is to discover and fix bugs because you have to go back. There are also some anti-patterns here. These two, from the same book, Software Engineering at Google. The ice cream pattern also has manual tests up here, which is very bad because you have to have a human actually doing tests. So that is not scalable. And the hourglass pattern here has unit tests and end-to-end tests and very little integration tests. This is bad because it doesn't catch bugs that could have been caught at earlier stages. And as we said before, catching them at the last stage is the most expensive way to do it. There's also this pattern, this is an anti-pattern, but it's advocated a lot in client-side applications and user-focused applications. It's by Ken Sedots of React.js fame, and it encourages a lot of integration tests. So my point about this is there's no one-size-fits-all, and your team has to agree on how to go about what tests to write. The other point that I want to make is that unit tests provide the highest ROI, return on investment, because they are faster to run, probably faster to write, and the feedback loop is very short with unit tests. However, their main drawback is they don't test component interactions. So what do I end up doing? So without looking at the test pyramids, I realized that myself, I tend to write more unit tests or more unit-ish tests when it comes to code that talks to the database, such as code and models, such as queries at function, for example, in models.py. Whereas the closer I get to the user or to the client API, the more my tests start looking like integration tests. As I said before, if I'm testing the code in a Django REST framework serializer, I sometimes just use it as client, and that hits the view, hits the URL resolver, and then the serializer itself. So we have some definitions done. So let's see how to write the tests. And I would like to go, before going through the do's and don'ts of how to write tests, through what goes in our mind when writing the test, when thinking about the test. And this diagram is from a book published in 2000 with research papers. It refers to from the 80s and the 90s about code complexity. And here you can see that this is the flow, the logical flow for a sequence, and whenever you had an if, then you have a new logical path. So white box testing is about exercising all possible paths that your code can go through. And it is a very exhaustive technique, and we'll see that if you have an extra path. If you have a Boolean operator, you have an extra path. So this is from Radon, which is a package that analyzes cyclomatic complexity, also known as McCabe's complexity function. So these are about executing all possible logical paths in your test. So let's get a very small function here. You have a customer, email first name and last name. If the email is set, return the email. If the email is unset, try to return the name. If both first name and last name are set, otherwise return not available. So if we try to use white box text testing, we would have 8 tests for this simple function. We would need 8 test cases. So with all the states. So black box testing comes to the rescue, and with a technique called equivalence partitioning, we decide to narrow down the tests we need just to 3. One, and here the focus rather than on the inner workings of the function, we focus on the behavior expected of the function. So we just write 3 tests and test the behavior that way. So we have gone through what tests we should write, what goes in our mind when thinking about tests. So let's go through the main course of the style guide, which are the do's and don'ts. So when you have tests, you have to agree about the structure of those tests. So if you have a piece of code in a module, you don't want to think and try to figure out where the test for that code is located. So ideally, there is a predictable way where your tests are located for your code. So a common style is to have tests reflect the structure of the code. So this is my Django app, and I have a forms directory with an orders and customers module in it. So I have test forms and test customers and test orders. So anything in customers, you can find it here. Anything for models, you find in test models, and so on and so forth. There is no best or worst way to do this. Just have one and stick to it so that people do not get lost finding tests. So that's one thing about the structure. The next, that's one thing about the folder structure. Now we have to agree about the structure within the test itself. And the pattern, which is very useful and leads to the expert chunking I mentioned earlier, is given when then. So a given when then gives structure to the test. So we put the given code here, when and then. So we separate the tests into steps. An alternative is called arrange, act, assert. So in this section here, we are arranging the setup data for our function. Here we are calling the target, and here we are making our assertions. The more tests you write and you keep a structure, makes it very easy to, when you come to look at a test, you know with the combination of comments and white space what each part of the test does. So since these are inline documentation, maybe having a more human-readable string would have been better than when created today is called. Here this comment here leads me to the next slide, which says, use verbose tests and function name. So here I have the serializer for the customer model, and the serializer is validating that when name information is provided, both first name and last name must be submitted. So how do we write tests for that? We test the behavior. And it's very useful to get a glimpse, an immediate glimpse of what the test is doing to write about the behavior, the expected behavior of the test within the test, within the function signature. So do not be afraid of having long test function names. No one will be calling these. So there is no, the more information you provide, the faster it is to read the test later on. Also, do use test case and test naming conventions. So customer serializer results in customer serializer tests, and validate results in test validate, test underscore validate, and then the state or behavior description that you're doing. There is no best way to do this. Just agree on one and follow through with that. This is very important. A test should test only one behavior. If you try to have a test testing more than one behavior, it's confusing, it's unmaintainable, the test itself might be flawed. So keep it simple. When it comes to unit test, to test code, then don't worry about having code duplicated. And that brings me to the next slide. Don't try to dry. Dry is don't repeat yourself. When it comes to tests, repetition is not a bad thing. Actually, if it makes your tests more readable, more independent of each other, then duplication is not bad. Remember, do not put logic in tests. It's another point of this, because sometimes when we try to test more than one thing in the same test, or avoid copy-pasting things, what we do is we stick an if or a for loop in our test. And if we do that, it means that our test now needs another test for the test, which so no logic and copy-paste is good. Another principle that I like to have followed in tests, and I do the mistake myself, is locality of behavior. This is an essay from the HTMX author, and locality of behavior means if you look at a file or if I look at a function, I know immediately what that function does just by looking at the function's code. Now, of course, it extends test case, so there are a lot of built-ins. But if I'm familiar with Django's test case, then if I look at the function, if I look at a given when-then structure, I know exactly, I don't need to think that much to see what the code is doing. So locality of behavior, try to locate everything your test is doing within that test. And this something that a mistake that I have done myself is to have test data classes with setup test data class method. If you're unfamiliar, we have the test case class in Django offers either setup, which is run for every test, or setup test data, which is run once per the test case. What I have done, a mistake I have done in the past, is having a hierarchy of test data classes, each calling the parent, and then if I need to see what state is being created for my test, I need to traverse manually through the hierarchy to see what the state of the data is for my test. So that is a mistake, and ideally your test at the cost of duplication should have everything within the test itself, and avoid test case hierarchies as much as possible, because then it makes it hard to see what your test is actually doing. This brings me to test data setup. So please do not use fixtures for tests. Fixtures are very easy to create, managed by dump data. You have a JSON file, you can use it in tests. Django makes it very easy to use fixtures, but they are not intended to be used that way. So you have a JSON file. Let's say you add a new field. What do? You edit it manually. How do you go about it? Also, fixtures tend to be append only. So if I want to create new test data, I just append to the existing fixture, and then all my tests use that new state that fixture is loading. And also, fixtures are very slow, but that's another topic. So compare that to using factories instead. So in the Django space, we have Factory Boy and Model Bakery, which are two very convenient packages to use for setting up data and tests. So here, I edited the customer model we had earlier to have a code, and the code here is not null, and therefore I configured the customer factory I had earlier to have this new code column here, and whenever I'm not providing it via the factory, what Factory Boy does, it sets it to have this default value with cast hyphen and a sequentially generated number. So that's all that I needed to do to have the previous tests passing. In addition, I changed the previous function so that instead of not available, it returns the code since it's not nullable. And the only test that I needed to change was this. I changed it from not available to return code, and I'm passing the code so it's hard-coded, and I don't need to think about, I don't need to assert again the customer code. I can see what's happening here. So you can see that factories make test data management much easier. And also the point about these given when then strings is that you have to maintain them. So this is a mistake I do continuously. I always forget to maintain them. So that consider using them only for the most important or most complicated tests. Another two don'ts here. Here I'm using, so don't use numbered variables. Here I'm just calling them order 2, order 3. And instead I could have called them order created yesterday at midnight or past midnight. Having the assert query set equal using that would have been much easier, would have been more human readable. In addition, I'm avoid having the tests, allowing your tests to talk to the system clock because it makes them non-deterministic, because if they depend, if the system clock is not frozen, your test behavior will vary depending on when they are run. Use Time Machine or a package like Time Machine or FreezeGun to freeze your date times. Use clear ferial messages. We can see the difference when you use assert in instead of assert through. The error message here is more helpful than the error message here. And Django itself provides a lot of assertions. This is from simple test case. There is a whole hierarchy, and I default to use the last one in the hierarchy myself because it provides all the goodies provided in the classes it extends. This is very important and probably is why I end up using more tests that look more like integration tests whenever I'm dealing with URLs and whatever the outside world sees of my Django application. So when here we have a view, a list view, and it returns the items for the user. So here I'm creating a couple of users, and then I'm creating 2 items for the user, and then another item for another user. I'm assigning the user to the request object. The request, I'm instantiating it, and then sticking the request to the view, because since I'm not using the client, I have to do manually what the authentication middleware usually does. So then I can test the context. So compare this when using the client. You just force the user, you assign it to the client session, and the code is much simpler. In addition, you can see that with less code, I get more return on my test effort investment because I am testing the mapping of the URL to the view and to the build-up of the context. So ideally, test behavior, not internal logic or state, as we have here. A final, my last 2 slides, one is about mocking and the other one is about coverage. So whenever you mock, you replace the component in your target with some other component, with a mock. The more that changes the behavior of the target, and the more you change the behavior of the target, the less accurate your test is. So mock carefully or sparingly, and ideally use, for example, instead of creating requests, use request factory when instantiating requests during tests, and otherwise use auto-spec. So what if you don't use AutoSpec, what mock does, it creates, whenever you access an attribute on the mocked object, mock returns another magic mock. So the idea to use AutoSpec is to limit your code, to limit the possible errors, to make the target as accurate as possible. AutoSpec has its limitations because it only provides the attributes defined on the class. For example, if an attribute is instantiated in the constructor, that is not available for AutoSpec. So again, this calls for the engineer judgment. Do use a convention for where to apply mocks. So I prefer to apply decorators so that I avoid the with statement context measure. In fact, I like the code in my tests to have no lines of indentation at all, so that I need to think less. And also do use a convention for naming mocks. So if you're using the decorator, make sure you use the mock underscore prefix or a p underscore prefix or no prefix at all, perhaps. And if you decide to use a package as an add-on to mock itself, mock is provided by Python standard library, like request mock, make sure you use it across the code base, not sometimes yes and sometimes no. Final word about coverage. Do play the game of test coverage. And coverage on itself is a very dumb metric because we could go from 0 to 80% coverage just by executing the test client code, by running the test client against some URLs, and so that we have a lot of coverage. That itself doesn't improve the correctness, or doesn't test the correctness of the system we're testing. So what should we cover? And the Beyoncé rules apply. We should cover anything that we don't want broken. And if we want that gradual improvement towards coverage over time, the way to enforce this is to ensure that no PR reduces coverage. So anytime you open a PR, we want a non-negative coverage number. So that was quite a drive through the do's and don'ts. These are the books I refer to mostly, but I will provide a whole list of references with the talk link. These are more theoretical in nature. These are more practical. This one, while published in the 2 scopes of Django that I referred to, while published in 2013, is still very much up to date, even though 10 years have passed, which shows how mature Django is as a framework. And this one by Adam Johnson is more about execution of tests, but also has some chapters which are very good which provide very good pointers about how to write tests. So the takeaways. So the style guide. So the style guide is a work in progress on which team consensus is required. It is no silver bullet, so it shapes behavior over time. And having a style guide, even if the style you agree on is not that good to start with, it makes it easier to migrate to a better style going forward. So definitely, I hope I convinced you about it. Regarding what tests and how to write them, I hope I convinced you that joining a project which has been there for 10 years, it's better to join a 10-year-old code base with a predictable and consistent style than a 10-month free-for-all project. And my final note is that code is read far more than it is written, so make sure you write the tests you want to read. That's it.
Really good talk. Thank you. We are ready for questions. I guess we have room for a couple of questions.
Yes, go ahead.
Anyone in the audience? Yes.
Hi, great talk.
Thanks.
One question, you had this one test case shown where you would say, I'm asserting the name of the customer, like test customer, and then you setting it in the factory boy, and then you're asserting it. And I'm always struggling to put this in a variable or not, because it's inside this test and it's duplicate and it feels wrong, but I usually never do it. So what's your take on this?
I think I wouldn't put it in a variable because I'm not afraid to repeat things. I think having it there, it's easier to see if there's a mistake. In the unit test, it's easy to spot. But I did use variables, and now I don't do it anymore. So it's not a again. I'm not the authority on this. It's a sample. It's a minimal style guide with style guide contents that might go into your style guide, but you and your team decide. But just decide on one and stick to it. That's the point. Thanks.
I have a question. Would you consider naming the style guide? I'm thinking about maintaining projects, and then there is a contribution. Hooray, someone fixed a bug or added a feature, but they didn't write tests, or the test doesn't like follow a style guide. Can make it easier perhaps to refer to it.
So in my talks references, I put a couple of links to a couple of style guides. One of them is by Octopus Energy, and it's very exhaustive. So if I understood your question correctly, is it about how to install a style guide? You don't want to enforce a style guide on anyone, kind of. So I'm not sure I understood your question.
Yeah, so kind of like the contributing guidelines for the random open source project, and
okay.
I want to say, can you follow something like this?
Yeah, ideally, but it's a long presentation, so it would be even longer to write it and provide samples. But ideally, yes, do's and don'ts. The format is quite helpful at what if you do something, I'm doing this, so I shouldn't do it. I should do the alternative. So the do and don't format is quite helpful in that case. I'm not sure about whether the Django itself contributing to Django docs have a style on tests themselves. As Sarah said earlier, it's a huge project with a huge number of tests. So my talk is more affected by closed projects for businesses. That's where my background is. But yes, I think a style guide, if anything, it helps people improve their coding practices. So yeah, it's a good idea.
Do keep a style guide.
Yes, definitely. Was there another question?
Yes.
Yes, hi. You talked about not using fixtures and tests, and you provided the example, what happens if there's like a change to it, migration or something. Sometimes you're forced to have fixtures just because it's like a legacy app and there's like a whole complicated thing that you need in the database to run the test. What I've done in those cases is I've added like a part to the README of like how do I upgrade our test database, which is basically like delete your SQLite database, run the migrations up to the point where the fixture was created the last time, load the fixture into your local SQLite database, run all the new migrations, and then run unload it back into a fixture and put it back in the repository. But I don't know if is there a better way of doing this, or it's like a standardized way of handling this? Because I mean, this is just what I came up with myself.
How do you manage the transitions when the schema changes? How do you regenerate? That's the biggest headache that I had when using fixtures.
I mean, let's say there's a migration that has like changed something, no? Then that's why I delete my developer SQLite database, load the fixture into that, and then run all the migrations that have happened since the last time. So now it should be up to date, and then I dump the contents back into the fixture, and then I upload the fixture to the repository, and now it should be up to date. And of course, this works until next time there's a change, and then the same procedure has to be done again.
Yeah. So the idea here is that So the fixture makes it very hard to read, in my opinion, what's in it. So if you use factories, you have, if you use something like Factory Boy, you have an initial effort where you have to model all your data using factories. So you configure some factories with sub-factories, for example, to create related objects. But the migration from fixtures to factories would involve an initial effort where you have the same data created by the factory code. Then that would make it much easier when you have schema changes, for example, because with Factory Boy, you either provide a default or not do anything, and it just works without any effort. But there is an initial effort to migrate from the fixture to use factories, and if it's a lot of data, factory functions provide functions to create batches of data. So yeah, it is a one-time effort, but I think it pays off going forward.
Quick question.
Yeah, quick question. Thanks so much for the talk, Joseph. I wanted to ask about where, if you have any more tips around where to put tests. I think sometimes it can be really nice and easy. You know, you have a test file already that tests a specific form. You're adding some functionality to that. You know exactly where the test needs to go. But what if it's like less clear? Do you have ideas about like should it, you know, one code file map to one test file, or any more pointers around this problem of, okay, I've written a new feature, now where the hell do I put my test?
So yeah, yes, it's a very good question, because this challenge I encountered it several times. So again, we go back to the definitions. What are we testing? Is it a unit test or an integration test? So maybe unit tests can have this structure where they are located, and you have a structure which reflects that of the non-test code, of the production code. But for integration tests, you might have an additional directory that is structured around the behavior, the name of the behavior you're testing. So we had a customer. So for example, if we had a customer lifecycle in which we want to execute multiple steps that talk to a lot of different modules, then we would maybe create an integration tests directory, and we call the modules by the behavior they test rather than by the location of the code. So yeah, that is something the team has to discuss, and everyone should be on board with it, because there is no one size fits all for this kind of question. But it's good to separate between unit, and that's maybe why we should separate between unit and integration test, maybe to locate it and style it differently, the code that results. Thanks.
I'm afraid we don't have more time for questions, but Joseph,
Yeah,
can be found in
yes.
in the room. Let's give Joseph a big hand.
Thank you.
And as maybe you noticed in Joseph's slides, then there was a reference to the next speaker, to
Yeah,
to
Mareike.
Yeah, who is